Let us go through the geometrical interpretation of simple harmonic motion. Take a particle P having uniform circular motion about a circle of diameters XOX dash and YOY dash. The XOX dash is the horizontal diameter and the YOY dash is the vertical diameter. An instant of time, the particle be at point P and let it make an angle of theta with the diameter, and that theta is equal to omega t. Here theta is equal to omega t. The radius of the circle is A, and now we will see the projections on the YOY dash and XOX dash. Let us take its projection on this vertical diameter B equal to M. Now, as we see, this is equal to theta, this is equal to theta as alternate angles. Let us take the triangle POM. In triangle POM, sine of theta is equal to sine of omega t. Sine is equal to perpendicular by hypotenuse. This perpendicular is equal to OM and hypotenuse is equal to A. So OM is equal to A sine of omega t. So the projection of this particle on the diameter is equal to OM, that OM is equal to A sine of omega t. We will see that if the particle starts from here, the projection on this diameter goes from 0 to maximum. When it goes from Y to X dash, the projection comes back to the 0 position. And now if the particle goes from X dash to Y dash, that means the projection on this vertical diameter goes from 0 to maximum. Then when it goes from Y dash to X, this particle, the projection again comes back to 0. That means the projection of the particle goes from mean to extreme to mean to other extreme to mean. That means the projection of the particle moving in a uniform circular motion on this vertical diameter executes simple harmonic motion. Similarly, if we see the projection of the particle P on the horizontal diameter, that is N, we can see that in triangle ONP, the ON divided by OP is equal to cos omega t. So ON is equal to OP is equal to A cos omega t. That means ON is equal to A cos omega t. It refers that the particle has started its motion from the extreme position. When the particle is at X, it has already its projection on this horizontal diameter is maximum, that is A. When it goes from X to Y, the projection on the horizontal diameter decreases from maximum to 0. When it goes from Y to X dash, the projection on this side goes from 0 to maximum, then it goes from maximum to 0, then 0 to maximum. That means the projection of the particle on this horizontal diameter executes SHM. But in this case, the particle starts its motion from the extreme position. In this case, the projection or the particle starts its motion from the mean position. That means when a body is having uniform circular motion, the projection of that body on any of its diameters executes SHM. The particle is itself in uniform circular motion, or the particle itself is having uniform circular motion, but the projection of the particle on either of the diameters, whether horizontal or vertical, executes simple harmonic motion. This is the geometrical interpretation of simple harmonic motion. Now, if we see the projection on the vertical diameter, Why? Oh, why? It can be shown by the sine function because the projection goes from 0 to maximum value, then maximum to 0, then 0 to maximum, then maximum to 0. If we see the projection on the horizontal diameter, that is XOX dash, the projection goes from maximum value to 0 value. That means it is shown by the cos function, like OM is equal to A sin omega t, ON is equal to A cos omega t. OM is the projection on the vertical diameter and OM is the projection on the horizontal diameter. Hope you understood.